Morning.
Well, I hope you had a great and restful Thanksgiving. Oh, I think if can you go back to the first slide, please? Let's start. We'll install it later, okay? We'll do it later. Thank you. So let me start again. First, I'll be a few minutes late. Sure, it's okay.
After this, we got this.
We can repeat again. Please, there are some donuts for those of you who did not have a chance. Get your energy bar before.
What's the name of the file?
While we are setting up, folks, good morning.
Good morning. Please listen to Dr. Memali.
What you appreciate about you. I'm sure that the director of our program, well as our farm, and you are so key for our programs as well. So when I heard about this opportunity, I've been so inspired. So thanks to you all and the professor and all of the team. And I was thinking this should be published because you now became producers of knowledge, right? Say yes, which is a great thing. And I just mentioned Dr. Fairs about publication, which looks like it is already going to happen. So congratulations to all and keep up the great work. Thank you.
Thank you. Thank you, Dr. Memali. Thank you for your support. And this is good for our students. We would like to support them so that they can perform at their best. So again, welcome to AGRO 5366, Principles of Environmental Science and Management, the last day of this course for this semester. So, and it's about term projects presentations. Our students have been working the entire semester on these projects that they're going to share with you. So I hope you will enjoy them, and I hope that you will give them some feedback, because ultimately that, as Professor Memali mentioned, that we need to publish these works that these students have been doing. So we are working on a book project that will be part of some of these chapters that make the quality control exam test. So which I don't have any issue with that, because our students have been really working very hard on this. Before we start, I just want to, I think from the get-go, thank our students for their effort, but also thank our mentors who really were instrumental in helping and working with the students. I think you all agree with me that they have been really working busy, especially the last few days, working with the students, sending them feedback and giving them feedback about their term paper, about their project presentations, right? And so on. And they will continue working. And that's to start from top, Dr. Anwar Adam there. He's one of our postdoc research fellows here. Dr. Anup Vital is a research assistant professor. And Dr. Rahman, he just excused himself. He another research associate professor who have been diligently working with our students on these projects. So to give you some instructions for our students, so we have like mainly teams of 3. They're going to be presenting the topics, and one team or one team of one person, Mr. Spivey here, he's going to kick us off. So the thematic is about emergent pollutant, and more importantly is AI in emergent pollutant, which is, I tell you that our students are really ready for the future, ready to tackle the issues and to use the latest technology, the latest analytical solution to address the problems that they will be finding solution for. I just want to remind them that you will have 16 minutes per presentation. So, and they kindly, 18 minutes, I think, 18, sorry. It's 6 times 3, 18. My math works. So I think we will be evaluating you. There is a rubric that we're going to be evaluating you. Also, we would like your colleagues to get your feedback as well. So each one of you here doesn't have to be a student, but we would like your feedback for our student about their presentations, and also anything that might relate to their written document, which is the report or the future chapter. With that, I would like to ask if you have any question before we start about what we're going to be doing, okay? So I would like to thank our online audiences. So I encouraged my students in fundamental value engineering to come and attend. If they want, they will get 5 points in their finals as extra credits if they come and attend, and 2 points if they attend online. So you might have some student who will show up to support you and to learn more about this topic. So with that, I would like to introduce to you our first speaker, Mr. Christopher Spivey. He's going to be talking to us today about balancing digital growth and water sustainability, a review from the Mississippi case. With that, Mr. What? Memphis, Tennessee, not Mississippi. I don't know where Mississippi. Oh, Memphis. I'm sorry.
We all connected.
Well, I mean the Mississippi River, right?
Exactly.
It has to pass by Memphis before reaching Mississippi.
Exactly.
So that's,
And we're on the state line too. So
There-
we'll talk about that.
there you go. There you go. So with that, Mr. Spivey.
Yes, sir. All righty. Thank you, Dr. Ferris.
You're welcome.
I also want to thank Dr. Vitil because he assisted me as well on this. So
You give him a warning.
XAI
Okay.
and Memphis. Now, when I started this, it was about taking something from me being at home, my city, Memphis, Tennessee, and, you know, a place where, you know, I've been at for a while and now here. But when Dr. Ferris, you know, said to me about the XAI and the water and what's going on there, I was like, okay, let me look in my backyard. So now, just to give y'all some backstory, I started this looking at the past and moving forward. So 1968, Memphis, Tennessee, Dr. Martin Luther King entered the city, came to the city based on a sanitation strike for the sanitation workers of the garbage, you know. Now, 2 men died February 1st, 1968, from being in the back of a garbage truck. Now, there was a bunch of things going on, labor, people just wanting to have equality in their jobs and also in what they were doing in terms of the environment, garbage, et cetera. But after those men died, and then Dr. King being there, April 4th, we all know April 4th, 1968, Dr. King was assassinated in Memphis, Tennessee. Now, 2 weeks after that assassination, the city came to an agreement with the garbage workers in regards to what was going on and them environmental justice and the workplace and things that were going on. So to fast forward a little bit, we see that the government and the municipal government per se, you know, knew what was going on and they could have made changes in these things. Now, when I looked at that and I looked at today, XAI, we all know about Elon Musk and the data center. Now, in Memphis, Tennessee, the largest data center, if I'm not mistaken, in the world is now in my city. So the Colossus Data Center. There's one on what we call Riverport Road, we call South Memphis, or it might say Boxtown. Well, that data center currently is at an old site that were some places in industry that did a lot of polluting. Now, it's right next door to a water treatment plant. And what the data center is currently doing, and there's no awareness in that, but looking at how it does cooling, and that's three parts. Looking at how it does cooling and what's being told to the people in the surrounding area. So currently, before I go to the cooling part, currently, there is a lot of water that is being discharged that contains toxins, et cetera. There's also quite a few things going in the air from the methane gas turbines that are running. So, of course, these turbines are releasing nitrous oxide as well as formaldehydes in the air in the surrounding area. According to the EPA, this could be on its toxic registry in terms of the pollutants that are coming out in the air. Now, to get to the main point, the data center and its servers and cooling those servers. So in Memphis, cooling those servers, they use towers, and I'm gonna break it down. They use towers to cool these servers. Now, the servers are not in the towers, but the servers release heat to what they call a heat exchanger. The heat exchanger goes to the tower, and then the tower is, the water they use is pumped to the top of the tower and is filtered downward. Now, downward to cool the heat that is coming through there, and they say evaporative cooling in that process. Well, the water that is still there, if it's not evaporated, that water is still going down in this tower and is captured in a basin, that downward flow. Well, sometimes in those basins, the water isn't totally captured and it is discharged away from the tower or on the grounds of that site. So now the water that is used to cool these items often has biocides in it. Biocides meaning stuff like chlorine and bromine in order to kill bacteria and other things, and what they call that won't build up in the bottom of the tower. So they use the word scaling. So things that crust up, they don't want that. So they use those chlorines and other things. So that is also what is wasted from discharges in the community. Now, the site states that a little about 49% of the water is coming from the wastewater treatment plant. Now, there is a wastewater treatment plant right next door to this site, and the knowledge that I found was that there's still more research needed to be done because there's no knowledge based on going on in terms of what the water treatment plant is doing with the water that is being used. So we'll call it non-potable water. Potable water, water that could be drunk or drinking, and non-potable water, water that cannot be used anymore. So there's still more research that needs to be done in that area in terms of using non-potable water to cool the servers. Now, I also found out in doing this research that another way that they're looking at doing cooling is immersive cooling towards these servers. Immersive cooling being using liquids that are non-conductive. So things that don't conduct electricity, and those can be synthesized in terms of oils and things of that nature. But the research is not there in terms of the effects in the environment. So that's one other piece in terms of the cooling part. The third way that XAI has talked about in doing cooling is predictive analytics. So predictive analytics in terms of cooling, well, they're using AI systems, machine learning, to predict when cooling is going to be needed for the server. And it seems to be that they're stating it will be better in conserving water in terms of what's going on. So in that predictive analytics, that is another way that XAI is looking at doing cooling. Now, I want to go back around to the municipal government and the individuals who are in power to say, hey, y'all are able to come and bring this plant here, this data center here. It's kind of the same dynamic we looked at from the past. Powers that be not recognizing what is going on. And to give an example, I looked at Flint, 2014, Flint, Michigan. So 2014, Flint, Michigan, basically the powers that be, the government decided to cut off the water that was coming from Detroit. If anybody's familiar with Michigan, cut off the water that was coming from Detroit and use the Flint River. Now, what they didn't realize and what they didn't know was, or I believe they did know, looking at the research, was that the Flint River had a lot of chlorinated water. When you take chlorinated water and you run it through lead pipes, it's going to become corrosive. And that lead went into the water stream. So that's all you heard about, a lot of individuals getting lead poisoning, so forth and so on. And I think some people died from those effects. Now, that's another case, 2014, but about 10 years ago, and we saw what happened, and officials knew what was going to happen. And we look at now today in Memphis, Tennessee, and looking at this kind of the same thing. I mentioned from the past, 68 environmental racism, as we would call it, and moving forward till today in a community of Black folks, predominantly Black. I mean, this is, in Memphis, Tennessee as a whole, has a population more than 6%. It looks like me. And a lot of times that things come across, there's no voice for the people who are being in those affected areas. Now, I talked about those three ways, and with the cooling, and also the effects of some of those, the water that's going on. Well, it could hurt the surrounding aquatics, the water. Some of those corrosive, the chlorinated water that's being used is sometimes discharged, and that could hurt the environment. So, I don't know if I had I know I've been taking off without any slides, but
No, the slides are going. So tell us which one do you want?
okay.
Next one.
So
Right now it's XAI sustainability claims. That's the slide.
okay. We can go to the next.
Okay. Research gaps and needs.
So right there, research gaps. I think I briefly mentioned in terms of the research for immersive cooling technologies. So basically, when I talked about fluids or liquids that are non-conductive, those were the research gaps are at now. There's no research being done on the toxicity that these have in the environment. So that's one of the research gaps that are there. Also, looking totally at the water treatment. There's research gaps in the water treatment and what's being done, because a lot of this is not being reported, and there's no government oversight. And that's another thing. There's no government oversight with the EPA and artificial intelligence currently. That's a problem. If you go to the next one.
This is the conclusions right now.
Okay, so now there's a lot of things that can be said looking at the municipal government from the past and where we are today. But it is basic in my opinion, but the research needs to be done in terms of looking at the different avenues of cooling with those towers, as well as what we could do. Now, it is said, and I don't want to forget my metric, and I almost forgot my metric, but water usage effectiveness. Now, water usage effectiveness is a metric that uses the amount of water divided by the amount of water, the power that is used in kilowatt hours. So that is a metric. And currently, I believe at the Memphis site, I think the number is 1.9. But that amount of water is being used in terms of what the electricity they're using. So that's something, and more research is needed in terms of those particulars dealing with that metric, the cooling, the ways of cooling, as well as what else is going on with the water there. So I say that to say, we still need more of us to take a look at some of those things, whether in my city, and it's spreading around. This is just not Memphis. New data centers are popping up in Atlanta and other places, as well here in Texas. But these are mainly being placed in marginalized communities where they know that there's not a lot of voice for the people who are in these areas. If I have to worry about going to work every day to put food on the table, to provide for my family, to pay my mortgage, you know, I'm not too much prone to worrying about what's in my water until it's too late. There are a lot of Memphians who have seen have gotten asthma, and the rates of cancer are 4 times the amount in these areas. So with that said, you know, I just wanted to thank you all and think about, you know, when you're using these artificial intelligence, you know, just put a little bit more thought to, you know, what's happening where these servers are and the water that's being used, or the pollutants that are going in our environment. So I appreciate it. Thank you so very much.
Well, we have a couple of minutes. We started a little late, but we have a couple of minutes if you have any question for Mr. Spivey.
Please.
Gianna.
I really liked your presentation, Mr. Spivey. What do you think on the aspect of the communities? What do you think these big technology industries coming into these marginalized communities? What do you think the industries can tell the people who live there?
What I think the industries can tell the people that live there.
Yeah, like what to expect in aspects of water usage or even power, or even more transportation needs, just because I'm sure that it brought a lot of good, maybe jobs, but also they might be bringing in transplants into the community that weren't there before.
That's a good question. I'm thinking on that one. That's a very good question. I think a lot of these businesses are strategically going into communities where the voices aren't heard. I think these businesses are going into communities like that are marginalized because they're not going to have to deal with so much of pushback, so much of getting things tested or what's going on. I think they could say, hey, go in and say, be upfront about the toxins that could be wasted, the toxins that could be going in the air or the water. But I think they could be more forthcoming in terms of any toxins that are being released in the environment, and what they're doing to mitigate those toxins.
Let's thank Mr. Spivey. And more suggestions and comments will coming written by your colleagues and our attendees as well. So let's go to the next team. Next team is composed of Kasaluka, and then Prantic, and then Kalpani. So these are going to talk to us about harnessing artificial intelligence for PFAS research, a critical review of detection, transport modeling, toxicity, and regulatory integration. So it's a review of the research that has been done on these topics. So with that, I will open the floor for our presenters. Each student going to present for 6 minutes. And then Dr. Vital here, when you reach 5 minutes, he will let you know that you have 1 minute to get ready for, so the next student will be presenting, right? So that we can keep going. Thank you. And we still have donuts, so, and for those of,
Hi, I'm Erin Andrews.
and I would like to welcome our dean who took time for his busy schedule and make sure to attend our graduate student presentation. Thank you, Dean. Appreciate it. Thank you, Dean. Appreciate it.
Thank you. Okay, good morning, everyone. I'm Kalpani Kenakon, and my group members are Prantik and Kusalika. So first of all, I would like to give my thanks to Dr. Alifaras and our mentors to giving this opportunity. So our project is on harnessing artificial intelligence for PFAS detection, transport modeling, toxicity, and regulatory integration. So this is the outline of our presentation. And moving on to the introduction, PFAS. So what is PFAS? PFAS is the acronym for per and polyfluoroalkyl substances. So this is a large group of substances, over 12,000 synthetic chemicals. And also it is characterized by carbon-fluorine bond, which is a strong and very stable bond, which make this compound persistent in the environment. And this is widely used in, since 1950s in the industrial processes and consumer products. And this PFAS is also known as forever chemicals due to its stability and persistence in the environment. So in this slide, you can see the sources of PFAS. So here, they can be found in everyday life, in food packaging, makeups, in every cosmetic products, water-resistant clothing, non-stick cookware, cleaning products, paints, firefighting foams. And here, the key message is that PFAS are present in every product that we use daily, even in candy wrappers. You can see many sources here. And this slide shows you the global contamination of PFAS. So each marker here, you can see it shows the location of how this PFAS has spread in water, soil, and also in wildlife. And also this is not limited to one region. You can see it is everywhere in all continents like North America, Asia, Europe, Australia, likewise. So that is the worldwide spread of PFAS. And let's see, why are PFAS a global concern? So first thing is, it is persistent in the environment. So this slide explains the PFAS is persistent in the environment because they don't break down very easily. That's why they called as forever chemicals, as I mentioned you earlier. And they have contaminated water, soil, and even remote regions like Arctic and Antarctic poles. And also PFAS also bioaccumulate in human and wildlife. So it builds up in blood and organs over the time in living organisms. And together, these factors make this PFAS a long-term global health and environment issue. And it also causes serious health effects, so which I'm going to discuss in the next slide. And also this use in many everyday products, as I mentioned earlier, in the sources of PFAS. So you can see firefighting foams and those kind of stuff. And it is very difficult and very costly to remove from the environment. So cleaning from drinking waterways, wastewater, or contaminant sites, it requires so much of advanced treatment technologies, and making remediation is technically challenging, and it is very expensive when it comes to the large scale. And these are some potential health risks you can see in the slide. So here it directly affects the immune system, and it may cause cancers like kidney, testicular cancers, thyroid issues, reproductive and fertility issues, kidney failures, liver damage, and also increased blood pressure and cardiovascular effects. So this PFAS has become a threat to human health. And let's talk about some key challenges in PFAS monitoring and remediation. So PFAS are extremely persistent and resist most conventional treatment methods. And they are very hard to remove from the environment because they exist in thousands. And so we have identified few standards in conventional methods. So it is very hard to detect. And also PFAS exists in complex mixtures. So many PFAS transform into persistent end products. And also it has limited toxicity data, making it very difficult to determine safe exposure thresholds. And it also challenges the groundwater systems. So it is highly mobile and hard to track in the deep aquifer systems. And also it is inconsistent and lacking limits worldwide, which makes regulatory gaps there. And also poor real-time monitoring. So they have few affordable sensors because the sensors which we use to detect PFAS, they are very expensive. So that is a major challenge. And also data integration issues, like complex data sets need advanced AI tools. So here you can see an example for using AI to eliminate PFAS. These two companies, like for example, IBM and Moore AI. So this is an example for industrial efforts, how they have bring some solutions to eliminate PFAS by using AI. And IBM Research, they have used Safer Materials Advisor tool. And in this video, it explained that. And Moore AI, that company also have put some effort to eliminate PFAS by using AI. So let's see this video.
Hi, I'm Erin Angelini, and welcome to Circuit Breaker, the news roundup from IBM Research. And finally, new screening tools for harmful materials. PFAS chemicals, which we've covered here before, are in so many products these days. But what if there was a simpler way to see if you can replace them in your supply chain? That's where IBM Research's new Safer Materials Advisor comes in. It's an AI-powered tool designed to help users identify and replace harmful PFAS chemicals. The tool scans chemical documents, flags potential PFAS, assesses regulatory risk, and even suggests safer alternatives. It can speed up the review of thousands of chemical products for PFAS by more than 4 times while reducing the chance of errors. It's a big step forward in helping industries transition away from hazardous materials more efficiently and responsibly. For more on
Okay, I think the video was not that much clear. So it explained how this IBM company has developed this Safer Material Advanced tool to eliminate PFAS, that one. So let's move to the objectives of this study. It's to analyze the different PFAS detection methods, including traditional and AI-based methods, and next to evaluate the applications of AI in PFAS detection, identification, focusing machine learning and deep learning techniques, and finally to identify cross-cutting challenges and propose future research directions for AI-enabled PFAS management. So now I invite my colleague Kusalika to continue the rest of the presentation. Thank you for listening.
Thank you.
Put the mic.
So, okay. Okay, thank you. I'm going to continue our presentation from the methodology. So at first, we have to select the articles for review. For that, we use these database. We use these databases I listed before to find the research articles. And specifically, we use a few keywords in here. The few keywords are the PFAS detection, the transport modeling, toxicity prediction, and AI application. And the time span was from 2010 to 2025. And finally, we collected 150 research articles, reports, and review papers. After that, three of us screened these 155 research articles and sorted up to 105 articles. And these are the number of studies used from the different regions in the world. And for our article, we separated into main sections, as I said before. Actually, in here, we mainly focus on the transport modeling, the AI for PFAS biodegradation, and the toxicity health prediction, toxicity and health risk prediction. So as I talk about the PFAS detection methods, we have two types. The first one is traditional methods and the second one is AI-based methods. So in these slides, I have explained the traditional methods. So in here also, we can identify there are main 4 methods. So these are the few instruments that we can use in these traditional methods. But the main thing is these instruments are very expensive and we need the lab facilities to operate these instruments. And we mainly focus on the AI-based methods in our review article here. And the methods are the machine learning methods, the deep learning methods, Bayesian neutral network, and the enhanced sensors. Actually, in here, we mainly focus on the machine learning and deep learning methods. In here, I have illustrated the difference between the machine learning and deep learning. So when we talk about the machine learning, so you can see there's a step called the feature extraction. So mostly the human is going to involve in here machine learning, but if you can see the deep learning, directly we are going to input all our data to our deep learning method. So machine learning. So what is machine learning mean? Machine learning methods it's actually a computational approach that allows algorithms to learn patterns from the data without being programmed. So as you can see in this picture, so we are going to input our data to the system, the machine learning methods, and actually the inside is like a black box because like we don't know what is happening there, but the regression, clustering, and classification methods are running through inside the method, and it's give the output. And we can use this machine learning to detect PFAS chemicals, as well as we can predict how they move in the environment. Also, we can estimate the toxicity level of this PFAS. And moving forward about machine learning, so we can find there are 3 main methods: the supervised learning methods, unsupervised learning, and the reinforcement learning methods. So in this supervised methods, we know the type of data we are going to input to the system. But in the unsupervised learning, we don't know what are the data we are inputting, like we are going to input to the system. So the system is going to identify through different processes. But when we talk about the reinforcement learning method, it takes the make decisions through trials and error. So with time, it's gonna get the best strategy. So I have listed the few methods as well. So you can see the random forest methods, the support vector machine, and the gradient boost models. So in random forest method, we can assemble of different decision trees, and the predictions are gone by averaging the previous results. So when you talk about the support vector machine, actually in here there are different boundaries. So based on these boundaries, it's gonna give the results. So in here you can see there are different boundaries called positive hyperlight, the maximum margin, minimum margin, like that. And this gradient boost model method, so actually it's combine the different multiple weak models and give the results. And finally, the deep learning model. So deep learning, actually it's a powerful machine learning approach. We can use in there, we can use like different layers to get the results. And there are some examples, the CNN methods, LSTM methods, and GNN method. And when we talk about the CNN method, actually it detects the patterns of images, signals, and spectral data. So as example in here, if you input any image, so after the several processes, it gives different results with the probability values. So we can select the highest probability value as a result in here. So LSTM method, that means the long short-term memory, So in here we can input the, like we can get the decisions related to trends, waves, and repeated patterns. And GNN method means the graph neutral network. In here we can learn directly from the structured data. As example, the molecules and different chemical materials. So this is the end of our methodology. So I would like to invite Prantik to continue the research and discussion.
Thank you, Kusalika. Good morning, everyone again. So I will continue from results and discussion. In this part, there are covered like 7 case studies. It's beginning from the microbial biodegradation to geospatial content, remote sensing, and especially groundwater treatment plants and so on. So let's deep dive on it. Okay, our first case study is in a AI-enabled prediction of PFAS biodegradation. So basically, it's contain the which microbial work best, like the biodegradation efficiency of PFAS under microbes. So we know some microbes, they have some activity to degrade the PFAS, especially on enzymatic activity, then microbial consortia, pH and redox conditions. So the key findings of this research was like GB, that is gradient boosting, random forest, and ANN model accurately forecast PFAS degradation rates in microbial and enzymatic systems. It also, the key recognition from this research, the chain length, then functional group chemistry, and the importance of this case study was it accelerated design how biotreatment system works, so that we can detect which microbes can degrade the PFAS. And it also helps select efficient microbial strains for PFAS defluorination. And our second case study was remote sensing and vegetation indexes that we all know. Nowadays, it's an important part, like remote sensing and AI, how can it detect and do works on PFAS contamination. Especially we know AI and remote sensing can detect PFAS stress in plants. You know, whenever PFAS is contaminating the surroundings, it can affect plant health, like affecting chlorophyll, then water balance and leaf structure. As we know, some satellite and remote sensing indexes like I marked here, NDVI, VCI and NDWI also monitor the wetlands, farms and river banks, so that we can easily detect where is the PFAS pollution occurring. And the key findings here, like hyperspectral imaging and CNN, can detect PFAS stress with high accuracy. And it also helped to map the PFAS affected areas at the landscape scale without needing many field samples. As we know, if we cover a large area with remote sensing, that can help in this aspect. And the importance of this study was it can detect PFAS contamination early in ecosystem, so that we can know like in which portion of our environment is polluted. Here is the third one. It's on geospatial deep learning work frame. So it combines in land use, rainfall, and hydrology system. It also detect the contamination in rivers, lakes, and watershed networks. The key finding of this case study, it also detect from CNN and special attention to identify drainage paths, like where is the PFAS going on. Like this picture, you can see this is the path. So the challenge of this study to detect the path, so that we can know how it contact with our environment. As you see here, this is the from the figure from the articles. The green spot, they are the sample connection point, and the red scattering things, they are the contamination of PFAS. So the tool also shows which downstream communities like which are in highest risk of PFAS contamination, and the importance of this study was supports proactive PFAS management at the watershed scale, so that we can know what is going on inside there. The next study, in this study, the researchers are doing work on the some special sources like AFFF, they are aqueous film forming foam. These materials are used for fire regulating things, like the firefighters work on it to remove the fire. So I can little bit explain how the AFF works. When fire is going on, it can separate the things and suppress the fire to different systems, so that fire can be go down. And as we know that this AFF contains PFAS, so around more than 1,000 global samples are detected by this method. And here is the case study 5. Not only in that study, we also find PFAS in a wastewater system. And here is the result, like in this research paper, researchers took around 200 plus wastewater treatment plants in California, and the dataset included around 931 PFAS samples in effluent and biosolids. Most interesting things here, when the researchers detect PFAS in effluent, they see like the PFCA content like 34 nanogram per liter, but after treatment, you can see here like the concentration is increased like 71 nanogram per liter. So from this study, we can conclude that like the PFAS content even not removed by the treatment methods that are we using in traditional systems. One more. Okay. And here is the case study 6. They also use their Raman spectrometry and machine learning to fingerprinting the PFAS method. They also differentiate around 40 different PFAS chemicals, and this spectrometry, you can see like different spectra from different PFAS systems. So the key findings here, this spectrometry showed clear fingerprint signals like CF2, CF3, and carbon-carbon bond. And the importance of this study, this also helped to separate PFAS mixers when traditional lab methods cannot do that. And this is the last one for our case study. In this method, the researchers try to find out the carbon and fluorine bond that we know our first colleague Purnima told, like it's a forever chemicals. So we need to find which bond is strong or which bond is weak. If we can find the weak bonds within the PFAS, and we can easily remove them from the environment. So researchers, they try to find out which bonds are weaker. And in this method, they can predict PFAS carbon fluorine bond strength with very high accuracy, and they got the R square value around 0.934, so that is really high in this case. So finally, in the conclusions of this study, we can say that artificial intelligence is an important tool to detect and monitoring mass faster and easier than the traditional lab methods. Then we can say that different machine learning models can predict the moving environment, how they move in environment, and help improve treatment system. And then we can say like PFAS how they interact with water, soil, and our living organisms. But still there are some challenges, the challenges are difficult to understand how the models make decisions and need to understand for reliable data sets. And even with those challenges, AI offers a powerful and promising way to improve PFAS management. They can reduce risk and protect the environment. And finally, our future recommendations for this, like use digital twins that can help simulate computer visualize method, and then we can combine different machine learning models, not rely solely on one models like DFT plus machine learning, remote sensing, and machine learning. And we can use explainable AI. As we know, like it's a black box theory, so we can trust the results, like why it's happened and why the models predict the results, and develop smart PFAS sensors. As we know, sensors is an important component here, so that we can detect the PFAS component. And finally, we should work together from chemists, engineers, data experts, and policymakers to collaborate the AI findings, so that we can really cope up with the challenge with PFAS contamination, and we can do our best for this PFAS. Thank you all.
Thank you, thank you. Any question
And
for
as
this team?
references,
Dr. Memoli has a question there.
Really, thank you all for tackling this very game-changing concept of AI and in science. So my question for this is that this whole the forever chemicals, we understand, and your research presented came from your AI application. And my question is, how do you ensure the reliability of the information AI uses as a reference? For example, one time I was so intrigued by a paper that I read through AI found, and I said, this is a Nobel Prize type of paper. So I went and found the paper, came to find out that they did the research using only 3 goats. You cannot do that. That information is actually misleading. So I'm curious to what extent you put the calibers for control or quality of the information that was used by AI to generate the conclusions you presented. What were the gatekeepers for quality? Thank you.
Great, thank you, Dr. Memoli, for this question. So the repeatability of the experiment, as I mean, maybe I can add a little bit more about what Dr. Memoli mentioned. AI hallucinates, for example. So how can we make sure that our findings are a proof of any error there?
As we mentioned, like it's a black box theory, as you know, like this era is on AI. So we recommend like explainable AI, so that why they predict result is like this way. So it can help, I think, explainable AI.
Okay, thank you. Let's keep other additional questions so that we can keep moving to the next presenters, and we will have more time at the end, hopefully, so that you can ask additional questions for the students. So let's thank them again. And next team is composed of Mansoura Mahmoud, Matilda Imoro, and Anita Kotokshi. So the first one, we're going to start with Matilda, right? And the title is Emerging AI Approaches for Identifying and Mitigating UV Filter Pollutants from Personal Care Products, a system review or systematic review.
Hi, everyone. So as Dr. mentioned, our topic is on emerging AI approaches for identifying and mitigating UV filter pollutants from
You may want to speak a little bit louder.
Okay.
Possible.
All right, from personal care products, and my name is Matilda Imoro. One may ask, what is the problem and what is the importance of this topic? UV filters are chemical compounds that are found in personal care products. We use these products every day, like sunscreens, makeup products, our pomade and everything. And this usually, they put in these chemicals there to prevent sun radiations. UV filters are more like, they are composed of either UVA and then the UVB. The UVA has the longer wavelength that can penetrate deeper into our skins, whereas the UVB has a shorter wavelength, and then those ones usually causes skin cancers and others. But UVA kind of causes tanning and also has some effects in also causing cancers and all that. Now, why is this an environmental concern to us? UV filters, as I said earlier, they are found in sunscreen and cosmetics, and they found their way into our water bodies through recreational activities. As from this diagram, we've seen directly they get into our water bodies through recreational activities like swimming, bathing, and others, and indirectly through wastewater treatment plants. Usually these wastewater treatment plants, some of them are not designed to remove UV filter pollutants because it's a new emerging pollutant and most people don't know about it yet. So even if they are able to, they are not able to remove it completely. And then those that are able to, discarding them is also a problem. So it finds its way back into the aquatic environment, and then it comes back to our drinking waters, and even through bioaccumulation, they get into our food. They also they are absorbent, so they attach themselves to the soil through sedimentation and stuff. So it affects both aquatic environment, it affects our human health, and it also affects terrestrial environment as well. So so they have bioaccumulation properties. They also disrupt aquatic species endocrine system. So this one usually, once they get into the system of aquatic animals or even humans, they mimic or either block some natural hormones in our systems, and then therefore they start to do their own things in the system and causes problems afterwards. They also causes oxidative stress, reproductive toxicity, and then biodiversity loss. And that is why we need AI monitoring solutions to offer innovative detection, monitoring, and treatment optimization in order to address these UV filter pollution. They are classified into organic UV filters and inorganic UV filters. An example of the organic UV filters include the oxybenzone, avobenzene, and others. They absorb UV radiations, both the UVA and the UVB. And then why is a concern is that they have bioaccumulation properties where they get into aquatic systems, aquatic animal systems, and then they stay in there causing endocrine disruptions as well. For the inorganic UV filters, an example is titanium dioxide. They reflect and scatter UV rays, and they also form nanoparticles in the environment, causing toxicity and oxidative stress. However, mostly people recommend using inorganic UV filters because they feel that one is more reliant and stuff, but then it also has environmental effects. And then why do conventional methods fail? Conventional methods is not able to address these issues because they are inefficient. Wastewater treatment plants struggle to remove UV filters. As earlier said, most of them are not designed to remove UV filters because this is a new thing in the industry, and then people don't really know much about it. So they are just there to remove the known pollutants, but not these ones. So that is why they are not, and also UV filters have chemical properties like hydrophobicity and then lipophilic and others. So they are not able to remove them. They also absorb to solids. Another one is that we can use advanced treatment technologies like advanced oxidation, membrane filtration, and absorption to remove these filters, but they are costly and they are even limited to us. We don't have access to them. Also, there is risk of transformation products where the treatment can produce toxic and persistent byproducts, posing even more additional environmental risks. Then the need for innovative solutions. Complex UV filters mixture then call for AI-driven models because we are not able to use these traditional treatment methods to remove them. And in view of that, we have, that brings us to our research gaps where there are few integrated studies. This is a new area of research, so very limited work combine AI and then machine learning to mitigate UV filters. Also, there are fate and transport modeling gaps. AI-based modeling of UV filter behavior is largely unexplored, so people don't know how they are transported, how they are moved, and all that. And research has not been much on this. Also, there is underused deep learning tools in this area. Then treatment optimizations also missing. We have minimal research on AI-driven removal strategies in wastewater systems, and there is no systematic reviews on this aspect as well. And that is why our study is much important here to protect, because we know now protecting our water quality and preserving aquatic systems and also ensuring safe resources is a key priority now. And then it's a key priority in the world, and protecting these ones depends on a robust monitoring strategies, timely detection of these pollutants, and effective mitigation. So by reviewing this, we are able to this research will be able to map the current states of knowledge in AI, and also to evaluate AI models' effectiveness in UV filter studies, to identify and propose innovative AI tools for improved risk assessment, and to also identify and propose pathways for future research. Now, what is the role of AI in removing UV filter pollutants? AI is able to process advanced data. We know environmental data is usually bulky. You combine environmental data, water, and everything, even with climate, so it's bulky. And therefore, our traditional treatment staff will not be able to remove them. That is why we need AI to remove these, to be able to accurately detect and predict UV filter pollutants. Also, machine learning and deep learning focus pollutant levels, and then they are able to identify contaminant sources effectively compared to traditional treatment models. Also, real-time adaptive systems. AI integrates sensor data with analytics to create adaptive framework that is able to help improve our water quality management systems. Also, it can also be used in decision-making to support proactive governance to reduce ecological risks and stuff. And so I will call on my colleague to continue.
Thank you.
Hello, everyone. Now I am going to present AI application and AI models that have been applied to detect, monitor, and clean UV filter pollution from personal care product. This slide shows different types of AI models and UV filter pollutions, application and limitation. First category name is deep learning. Deep learning models like CNN, convolutional neural network, autoencoders, these models are used to real-time detection of component like PB3 and avobenzone. And these have some limitation, needs large data set. Then second category is supervised MN model. Some model like reinforced RF, SBM, XGBoost, this model are used to forecast concentration pattern and water quality indicators. And another category is QSAR, like quantitative structure activity relationship, and QSPR means quantitative structure property relationship.
These models are used to predict toxicity and environmental fate for new UV filter molecules. Then the next slide is AI for detection. For detection purpose, advanced analytical technique are used. Some AI models like ANN, some AI models like random forest, convolutional network, neutral network, and group neutral network are used to analyze spectral data from UV visible spectrography and also help to accurate UV filter quantification ranging from 98 to 102%. When we combine AI and Internet of Things, this combine enables real-time monitoring by processing sensor data and also detect anomalies efficiency. This combination make detection more efficient, accurate, and for image-based contamination detection, AI use drone to identify contamination hotspot and also enhance environmental surveillance. Then my next slide is AI for monitoring. For this monitoring purpose, predictive AI model use machine learning and deep learning models used to analyze pollutant data to predict seasonal trends. Then when we combine AI and Internet of Things sensor, this combine enables real-time monitoring and alert for sudden contamination spikes. Some algorithm like auto encoder and this type of some algorithm are used to detect anomalies in pollution data. By predicting contamination hotspot, AI improves resource allocation and ecological protection. And AI for treatment. Some AI model like AAN, CNN, RF, this type of models are used to predict degradation efficiency of photocatalyzed like titanium oxide and zinc oxide with high accuracy. This model machine learning algorithms helps to estimate short capacities to optimize material selection of treatment. Some advanced AI technique like XGBoost and GNN, these data are used to design nanomaterials and with improved removal capacities. Some AI frameworks like SVM and RF, these models are used to reduce experimental cost and enhance treatment. AI for risk assessment. Some AI models like QSAR, SVM, RF, this model are used to predict toxicity bioaccumulation with over 90% accuracy. These models combine environmental parameters like pH, temperature, salinity to forecast risks under diverse scenarios. Explainable AI techniques improve transparency and build trust. AI reduce the need of animal testing and speed up the hazard evaluation. And my other group member Anita is coming.
Good morning.
Good morning.
So continuing from where Mansoura stopped, how can we use AI for a sustainable product design? So AI, eco-friendly, we can use this by generating eco-friendly molecular generation. This means that we need to consider AI. We need to focus more on generating molecular which enhances into the products, which enhances protection to our skin without polluting our water bodies. Also, hybrid AI systems. It is important to incorporate AI rules into the model from the very start of it. And also rapid iteration optimization. So this is important because human beings and AI has to work together in order to produce or design a better and sustainable greener product. Okay, this is next, right?
Yeah. Just,
Is this? Yeah.
yeah.
Okay, thank you. So in order to ensure a very sustainable product design, we need to analyze the performance metrics. So the key, some of the key metrics here is accuracy and precision, which encourage consistency. Now, AI should match with the real-time data that we have gathered. That is where R-square comes in. This evaluates the accuracy of the accuracy in the model better, and with RMSE, this is really essential model because it ensures how far the prediction is in the model. High predictive reliability, we need to incorporate, like I said in the previous slides, incorporating all these models would enhance excellent prediction quality, and also machine learning classification. We all know that this would help us sort and categorize this data, environmental data into the model. Now, spiral analysis recovering. This helps to analyze how UV filters absorb light spectrum. However, there are a few challenges in our distance. That is data scarcity and quality. AI needs lots of data to work with. Therefore, and there are limited availability of long-term and high resolution database. And secondly, model interpretability issues. So deep AI, this is used to, this deep learning model are often complex and hard to interpret. Therefore, this it becomes less likable for policymakers to consider it. Environmental transferability limit. We all know that climate, ecosystems, and environmental data varies from one place to the other. Therefore, this can be a very huge hindrance to the model. Integration and ethical governance. Successful AI deployment needs technical experts, institutional support, and framework to handle all the biases in the model. So with our key findings, UV filters persist and bioaccumulative, posing a very high ecological risks to both aquatic and then terrestrial environment. AI model accuracy. So this dictates detecting, monitoring, and optimizing treatment of environmental pollution, such as the UV filters. Emerging AI trends. Explainable AI and hybrid models are emerging trend aimed to sustainable products and improve environmental governance. Transformative potential. This finding emphasizes AI's transformative rules in advancing sustainable environmental governance and decision making. So some of the recommendation we came out with. So expand monitoring data set for UV filters, pollutants across all water sheds. Advanced multi-modal AI framework, combining sensors, spectroscope, and remote imagery for real-world monitoring of these products. Watershed integrates toxicity prediction with AI to design safer, eco-friendly, and products in the model. Watershed digital twin. This helps to develop digital twins of watersheds to stimulate and manage environmental system effectively. Open data sharing. There should be this open repositories across sectors, intercontinentals, to ensure transparency and then also research. Explainable AI adaptation. Use explainable AI to improve transparency and trust in the AI-driven environmental solution. So now, what
1 minute. Just
what's policymakers, scientists, and industry should do next? So this is really important because they are the drivers of everything in our society. So policymakers should encourage open sharing of data to integrate, to facilitate AI integration in the model. Also, we researchers, we play a very key role. We should consider interdisciplinary collaboration across sectors and also industry innovation. Adapt AI guide to next generation of UV. We shouldn't just talk about it, but we should also adapt it in the design model. So in conclusion, we should focus more on proactive environmental governance, support for human health, and sustainable, innovative policies, and then also resilient ecosystems. On this note, we would like to thank Dr. Rahman and then Dr. Faris for their support.
Thank you. Very good presentation. Really lots of information, and let's go to the next teams. So because we have time constraints, we'll leave time for the rest of if you have any question and answers. Okay, if you have any comment, please the forms that we gave you, feel free to add comments for your colleagues. We will share with them your comments as well. If you have any comments or input, I welcome your input on that. So Next team is going to be the first person who's going to speak is here. So it's going to be Damar, it's going to be 6'2", and also Chodahari. So we'll start with Damar. Go ahead, Damar, please.
Morning, everyone.
Good morning.
Beautiful weather we have, by the way.
Indeed.
So today I will be talking about our research. Well, it's a review that we're working on, and as the topic suggests, from detection to decision support, utilizing artificial intelligence for managing endocrine disrupting compounds. So my group members are Srijana Chaudhary and Dr. Sixto. So before I even begin, we'll be going over the objectives, well, the outlines. So the first presenter, which is me, I'll be going over the introduction, the objectives, and the methodology. The second speaker will be going over the discussion, which is Srijana. And then finally, Dr. Sixto, challenges, conclusion, and his acknowledgement. So firstly, what are endocrine disrupting chemicals? That's a good word, right? So EDCs are basically external compounds that disrupts our hormonal and our immune system, which cause significant problems, right? Some of them, they're able to mimic and block or alter our hormonal signals, which cause detrimental impacts. Some of these results in thyroid cancer, skin cancer, amongst others. But for this specific review, we're focusing on pesticide use, especially in the context of agriculture. So we're able to link EDC with reproductive problems, neurological problems, and immune problems in humans, and not just human, but also for animals as well. And when you're exposed to EDC for a very long time, it can remain in the system and also be transgenerational, which means it affects the future in the long run. Now, we're looking at the source. Like I said, for this review paper, we're focusing on pesticide use. So depending on the pesticide, a lot of pesticide, especially in the context of agriculture, contribute significantly to EDC, ranging from insecticides, herbicides, as well as fungicides, because most of these are used in the agricultural industry to apply to our crops for better performance or better growth in order to meet the needs of food security. So they apply a whole lot of these, and in the long term, it disrupts our chemical systems and throw the balances off, which causes significant problem in the later run. As like I said before, some of these includes your reproductive system, your metabolic relationships, and also contributes to thyroid hormone imbalances. And like I said, this also contributes to cancer. So this research or this review focusing primarily on those particular compounds first found in pesticides. So we're trying to narrow down on this review instead of having a broad spectrum where we're just focusing on every little bit of thing. For this research, we're focusing on a specific thing. So we're narrowing down to pesticide and not just looking at endocrine disruptive substances across the entire broad spectrum. Now, when we look at traditional, we are looking for detecting endocrine disruptive compounds. We're looking at traditional. Traditional means the outdated, they say outdated way of detecting endocrine disruptive compounds. So we have high performance liquid chromatograph, which separates and quantify endocrine disrupting chemicals in a liquid sample. And then we have the gas chromatography mass spectrometry, which identifies volatile and semi-volatile endocrine disruptors by a molecular mass. And then we have the liquid chromatography, tandem mass spectrometry, which detects endocrine disruptors at trace levels with high sensitivity and accuracy. Now, all of these are good for traditional approaches. However, it costs a lot of money in order to facilitate these instruments, right? And then you have to pay individuals who have the skill set in order to run and operate these machines. As well, facilitating these machines and running them and utilizing them costs a lot of money. So we have to start using emerging platforms such as AI and machine learning. And from there, there's many of them, but for this presentation, I'm utilizing 3. So we have the quantitative structure active relationship, the QSAR module, which basically predicts endocrine disrupting activities based on the chemical structure. So depending on the endocrine disruptive compounds, each of them have different chemical structures. So utilizing this system, we're able to identify the specific endocrine disruptive substances, right? For the spectral imaging and artificial intelligence, this combines spectroscopic data and deep learning for fast and non-destructive EDC detection. So what this is, think of it as light detection. So each molecular particles passes through light at a different wavelength, right? So if you're looking at different compounds, they pass through a different wavelength. So utilizing machine learning, they're able to predict different wavelengths of EDCs at different wavelengths. For electrochemical biosensors, it acts in the same guideline but different principle, where it utilizes electrical signals. So sensors, everything living and non-living, or whatever you want to refer it to, everything has an atom. So from that atom, they're able to detect different electrical signals from EDC. And that's how they're able to utilize these machine learning platforms in order to separate and identify individual EDCs that are affecting human health in the context of agriculture, which this paper is particularly focusing on. So why we utilize artificial intelligence and why does it matter? So firstly, AI refers to a computer system that can learn from data, recognizing patterns and make predictions or decisions without being programmed consistently. And there's also a difference between AI and machine learning. Some AI is like ChatGPT. You give it something and it just spits out whatever it feels you need. Whereas machine learning, you give it particular inputs and it gives you a particular output based on what that machine learning platform was programmed to do. So the conventional method or the traditional method, like I stated before, they cost a lot of money to operate, and you have to have the required skilled personnel in order to facilitate the use of these machinery. And it costs a lot of money, and it's very expensive and also time consuming. So which is why we are utilizing AI, which offers advantages by enabling the rapid screening of large chemical data sets and predicting the toxicology characteristics of these EDCs and their environmental behaviors, and then support faster and more cost-effective decision compared to traditional methods. 1 minute? Okay, no problem. So for this research, we're planning to create a comprehensive review of the traditional and emerging technologies used for detecting EDCs and to evaluate the role of artificial intelligence and machine learning in predicting EDC, and to assess how AI-driven tools can support decision-making for mitigation, treatment, and regulations, developing frameworks, and to bridge that gap between detection and modeling so that we get the right analysis that we need. So for this research, for the methodology, we applied the PRISMA method. So this map that you're seeing, this global map, is based on the reviews that we've gathered for utilizing the PRISMA method. So United States in this paper was the highest, followed by China. So in order for us to come up with this methodology, we apply the PRISMA method. So we followed a guideline. So we utilize our data sets, web engines from Google Scholar, Web of Science, and we keenly selected specific keywords through these data sets, and then we remove the duplicates. We scan the title and the abstract, and we use particular keywords that we are looking for in order to come up and carry out this review. And from there, we're able to separate and use specific reviews to carry out our review-based research. So our next speaker will be Srijana, and she will be talking about the role of artificial intelligence in assessing endocrine disrupting compounds. Please welcome Srijana.
Thank you, Damar.
Thank you. Oh.
Good morning, everyone.
Good
I am
morning.
Sridhana Chaudhary. Today, I am going to cover this topic, like how AI used used for screening endocrine disrupting compound, like how it works in bioaccumulation, persistent modeling, what are the detection enhancement. So first, my colleagues already mentioned about lots of AI model, like Kushalika, she mentioned about a support vector machine, random forest, and other colleagues also mentioned so many models. So today I'm going to what are the results after using the models, what will we get. So today AI tools like support vacuum machine model offer more accurate reproductive toxicity prediction for endocrine disrupting compound than traditional methods such as the ICE, which means interspecies correlation estimation model. And another one is there are 13 endocrine disrupting compound, including dexamethasone, PFNA, genistein, cadmium, and BPA strongly bind to these genes, suggesting a potential role in OP pathogenesis. Another one is QSAR models for 14 endocrine related receptors using conformal prediction and clustering, screen 55,000 chemicals, identifying 23 with potential endocrine activity and estimating prediction uncertainty. Another one is modeling 7,500 plus chemicals so that multitask neutral network improve accuracy, but combining multiple models provide the most reliable identification of potential endocrine disruptors. So another one is deep learning QASR model accurately predicted quantitative and qualitative and quantitative effects of endocrine disrupting compound on HBG and estrogen receptor, achieving more than 90% of accuracy and strong R square and Q square. The value is 0.8 to 0.86, outperforming traditional models. Another one is BCN model in SA Central accurately predicted estrogen receptor agnostic activity modeling or outperforming EPA model and helping prioritize chemicals for testing. Next one is US EPA, which is Environmental Protection Agency. ToxCast assays accurately predicted estrogenic and androgenic activity in EDSP tier 1 screening with balanced accuracies up to 1, supporting their use in chemical prioritization. Another one is random forest models from CERAPP and COMPARA dataset accurately predicted AR binding, agonism and antagonism with up to 93% balanced accuracy, supporting efficient chemical screening and prioritization. There are over 40,000 poorly characterized organic chemicals persist in aquatic environment, promoting the EPA, NOOA, and USDA to monitor their risks to human and wildlife using explainable ML and LIME. LIME key LIME key toxic structure, thiophosphate, sulfamate, anilylide, carbamate, sulfamide, and thiocyanate were linked to endocrine disruption across 5 receptor target, enhancing interpretability and chemical risk assessment. Another one is LCHRMS, non-target screening combined with structural alerts and machine learning, NN, and RF effectively prioritize potentially hazardous chemicals, achieving AUC ROC up to 0.97 and successfully applied to surface water samples. And this one is how this AI persistence and bioaccumulation of EDC. This shows like this shows like here there are so many chemicals which are contaminating our environment, and like how we used to how we use machine learning or models to uh, remediate that contamination from environment, like reduction, half, and degradation potential. There are some local and global bioaccumulation models. Local means like it used to remediate from individual organism which is focused on uptake and elimination, and global means it use go through the large scale, like in ecosystem or different species in food webs, which focus on bioaccumulation across food webs. Another one is multimedia fat model, which based on air, water, and sediment, and another one is like importance is that it used to first magnify and identify the contamination from the environment, and another one that this one is, and this one is like what are the setting of policies or regulation to release and to control the to control the that compounds, and the last one is remediation, like how we will use that method or that models to remediate or to control the contamination from the environment. Here, okay, I'll go to here. AI prediction of EDC, persistent machine learning, and QASR models can estimate the half-life and the degradation potential of EDC by linking chemical structure to their environment stability. Global versus local bioaccumulation model. Local models assess chemical uptake and elimination within the specific organism or sites, while global model predict bioaccumulation across environment, accounting for food web, lipid content, and tropic interaction. Multimedia fact model, fungicity-based model estimate the distribution of EDC across air, water, and air, water, soil, and sediments, integrating chemical properties, environmental conditions, and degradation rate to predict persistent and transport. What is the importance? Understand the persistent and bioaccumulation is critical for assessing the long-term environmental and human health risk, regulatory decision, and designing effective remediation strategies for the chemical for PCB, dioxin, and pharmaceuticals. Detection enhancement, AI enhanced analytical techniques like GC, HPLC, spectroscopy, and mass spectroscopy by enabling faster, more accurate analysis and interpretation of complex multidimensional data. Real-time AI analysis improve decision making, reduce error, automates work follows, transforming research in environmental and pharmaceutical field. Smart nanomaterials combined with AI-driven techniques like machine learning, predictive modeling, enhanced pollutant detection, separation, and environmental monitoring, offering sensitive, selective, and efficient solution for a cleaner, sustainable environment. The integration of AI with a wearable, implantable, and sub-sensor enables intelligent real-time health monitoring and analysis, providing precise diagnostic, therapy, and next generation healthcare solution. AI enhance microfluidic sensor, leveraging the nanomaterials and synthetic recognition element, enable real-time sensitive and selective detection, micropollutant transforming environmental monitoring and pollution management.
Another one is MS frag talks use high resolution MS data and machine learning to predict endocrine disturbing toxicity and high accuracy, that is 0.845, enabling rapid risk environmental risk assessment, targeted LC-MS and GC-MS accurately quantified endocrine disruptors such as 4-NPP, NPE, OPEON.
You don't have to give the list, you just highlights.
Oh, okay.
And take your time. I mean, relax, but highlight.
Okay. Okay, thank you. Clause at PPT, PBB level demonstrating efficient extraction and high recovery. MOS best technique knows combined with PCA, LDA, and SBM algorithms enabled rapid and non-destructive detection and classification of pesticide on apples, with PCA showing the highest accuracy. MOSES second electronic nodes with multi-sensor arrays effectively discriminated trace insecticides and industrial contaminant in water and solids, supporting environmental monitoring of hazardous residues. Another one is non-mobile eNose devices with MOS, QCM, CP, and HAW sensor enable real-time VOC and pollutant detection, supporting emission monitoring, pollution control, and clear industrial processes. And another one is an electronic tongue and carbon screen printed electrodes detected and classified pesticide in water with more than 90% of accuracy at 0.02 to 0.25 ppm and 100% of accuracy in a type identification using machine learning methods. There are some scientific impacts. AI-based detection technologies significantly improve seed sensitivity and accuracy, enabling real-time identification of endocrine disrupting compounds in environmental and food system. Another one is this innovation strengthen environmental monitoring and public health prediction by allowing early detection, rapid decision making, and more reliable assessment of chemical risk. Now I want to invite Dr. Sixto to continue the presentation. Thank you.
My name is Sixto Marquez, and this is my part of my presentation. As you know, AI, by using AI, we have to use AI, we need to use computers. So by using computers, and AI, we have the ability to analyze large data sets. And we can use different approaches to do that. We can use deep learning, machine learning, and which are predictive models. And by using that approach, we can mitigate the impact of the endocrine disruptive compounds. And with those approaches, we can do different, we can solve different problems. We can design chemical or biological interventions to mitigate the problems. That mitigate means that once the problem is present, we have to soften the impact of it. So we can neutralize the chemical, or we can degrade it. And by using AI, we can do that faster, by the use of modeling on computer. Also, we can predict enzyme substrate interactions to optimize the degradation of those products. And we can suggest the use of different type of absorbent compounds, to remove those chemicals from the environment. Also, there are some specific examples like this, that by using AI, some removal compounds were designed, and they were very effective in removing these estrogens disrupting compound from the water. This is a specific example. And also, by using AI, we can mitigate the problem. How? The AI can forecast hot spots in the environment, and by also it can predict the spread and accumulation of those disruptive compounds, and also it can recommend targeted approaches. That means that the AI can pinpoint those hot spots and recommend, it can tell where it is and how to remove, how to control that problem. Also, AI system can optimize remediation efforts, reduce operational costs, and minimize the ecological impact of it. In that way, we can preserve the environment and we can minimize the exposure of human beings to those problems. Also, the AI provides it mitigates the problem, by minimizing the exposure. We can save time and money at the same time. It makes more efficient the control of the problem, And also, to use AI, by using AI, we have more advantage because there are some regulations that were already established, but they have to be updated, no? And by using AI, we can gain knowledge and update those regulations, make them more efficient. And also, by using AI, we reduce the use of extensive laboratory testing. And that is that we don't have to use more animals, in the lab, or we can save chemicals and material, and we save time and money. And also, to establish those regulatory policies, in the US, there are two agencies mainly. The EPA, which is the Environmental Protection Agency, and the Food and Drug Administration. And international is mainly the UN, the United Nations Environment Program, and the World Health Organization. And in Europe, we have the European Union that, they set up they come out with a law, which is called REACH, in which all the steps and regulations are established to regulate those endocrine disrupting compounds. And in the US, we have the EPA, established this program, the endocrine disruptor screening program, to regulate the endocrine disrupting compounds. However, there is new knowledge being generated, and there are new approaches that must be established, new regulations, and these are some recommendations, like the policymaker must establish robust regulatory frameworks, and also, they must prioritize significant initial investments, the industry and the funders, to regulate the artificial intelligence used in this field. And also, currently there is something called Toolbox, OECD QSAR Toolbox. And this is a software which is used by the government and companies to identify endocrine disruptive compounds in the environment. And this is available for all the companies in the market and the government. And also, there are some ethical issues right now, because, since this is a new approach to regulate those compounds, there has to be clarity. So the models to set up to identify these compounds must be easy to interpret, and the predictions, the algorithm to identify the compounds, have to be open to the public, so everybody has to be able to access to them, and also the training data for the models and the performance metric must be validated. And why? Why? Do you know why?
Why?
Because if we make mistakes, so we can reach wrong conclusions, and these chemicals affect the environment and finally the human. So if we reach wrong conclusions, we may end up, affecting the health of the population.
Yes, that's true.
So this is very delicate.
Mhm.
Yeah. Okay. And also there are some challenges, in using this approach. The data has to be examined and has to be as good as possible, to reach those good conclusions and the high quality. And the models used, they have to be easy to interpret, so everybody has to be able to operate them in an easy way. And once it is done, it has to be, all these AA approaches have to be focused on a specific mechanism. And this is an example of a mechanism in which AA is currently used, these adverse outcome pathways that some pharmaceutical companies are using the AI in this field with this mechanism. And there are some challenges and future directions. For example, when it comes to environmental safety, the AI can be integrated with sensors, robotics, and data analytics to mitigate the risk and to improve, the performance of models and to achieve our goals, which is prevent the release of these compounds in the environment. And there are also challenges when using AA. There are shortages of professionals in the field because this is a fairly new field. We need initial investments to set up these AI technologies and companies. It requires high quality data. And also, to address these challenges, we need the participation of lawmakers, ethicists, data specialists, and the public to establish robust regulatory frameworks. And also the conclusions, the AA is a very helpful field, which is useful for toxicology and environmental sciences. It can be used in multiple fields, and it increases the efficiency by creating a chemical design, because AA can accelerate the risk assessment, optimize processes for enhanced safety, and improve regulatory compliance through predictive modeling and real-time monitoring. Also, it helps prevent problems created by EDC, leading to a more cost-effective solution in the long term. And all of this leads to a cleaner environment and a healthier population. Okay, and this is the acknowledgement.
Thank you.
Yeah.
So I think for a sake of time, we will go to the next team. So Shinadu and his team, his colleagues. They're going to be talking about AI application and pharmaceutical pollution research and management. Please be efficient. So I think 5 minutes will be good for them. These are very efficient people. Not per person, not all. Yeah. Okay.
Okay. Good morning, everybody.
Good morning.
My name is Ramira Kenzwa, member of my group, Chinedu Igwenagu and Mafred Igwenagu. Our topic is AI application in pharmaceutical pollution management. I'll go straight to the introduction. So we titled this like a silent pandemic. AI, or rather pharmaceutical pollution is kind of like a silent pandemic that's going on because most of the chemicals used in our medications are like forever chemicals, like they stay there forever in the ground, even after years of usage, they still stay there and they never leave. So like active pharmaceutical ingredients and their breakdown, their formulations, the process and everything, their sediment like it moves down to our groundwater, our surface water, even to our treated drinking water. Conventional treatment plants, they are designed, but basically they don't remove all these chemicals even after it goes through the treatment process. So it's a critical global concern because the sources result to like diffuse the spread of these chemicals, recurrent loading, and chronic exposure to different scenarios, making this pharmaceutical pollution a critical global concern and requires urgent attention and innovative solutions. Some major sources of this pharmaceutical contamination are from municipal, hospital, wastewater, and basically the wastewater treatment. If the wastewater goes to a treatment plant, the treatment try to treat it and send it back into our groundwater. In terms, we also pump this groundwater for irrigation, for our agricultural product, and also for drinking for our livestock. Also, this is all going back to our food and our livestock. And there's also improper disposal. Most times when we finish, when we have like expired medications, our first thought is to flush them. Just put them in the toilet and flush them. Those are like improper way of disposing these medications because they still go back to the groundwater, and this groundwater most of the time is our drinking water too. But there are the limitations to our current approach, like there's data scarcity. One of our colleagues also mentioned data scarcity, inadequate treatment. There's also inadequate treatment in the transferable issues and the issue of the black box. But AI as a transformative solution, it can do like advanced detection and monitoring, predictive map, enhancing and understanding, and proactive risk assessment. Also, we should know that these pharmaceutical contamination can also affect our environment and our health. So basically, it disrupts aquatic food chain through bioaccumulation, behavioral change, and reproductive interference. It also altered microbial community structure. The objective of these studies basically to and it's like AI-enabled detection and monitoring, including LC-HRMS, which is like liquid chromographic with high mass resolution and spectrum. Also evaluate the risk assessment, the AMR surveillance, including PBT flags and ARG load. Also reviews AI-guided treatment to optimize advanced oxidation processes and photocatalysis and biological systems. Okay, I'll let my colleague go through the methodologies and
hello, everyone. My name is Chinedu Gonago. I'll be covering the methodology. Now, we downloaded up to, we reviewed up to more than 100 of articles, and we downloaded, I think, up to 130, and then we screened. Next thing we did was screening. But before the downloading out, of course, we had to choose our topic. which thanks to Professor Anwar, he helped us to choose our topic. And then we downloaded these articles, we screened them, and out of 100, and I think 140 or so, we got up to use up to 108 articles. And then we used some keywords, that are related to pharmaceutical pollution. And then we extracted our information, and so let me go to the next. So I'm going to skip these two sections because of time, but I will come back to them. This is the most important section of most important thing in my section. So this diagram, I had to design it by myself.
Good.
It's just a summary of the linkage between how pharmaceuticals affect the environment and human health. The biggest issue, the most pronounced issue these pharmaceuticals cause is this antimicrobial resistance. This is because of the strongest pharmaceutical that affects the environment, that affects human health, is antibiotics. So this diagram is just the summary of everything my colleague said previously. This industry here, they are the ones that produce these pharmaceuticals. They produce all these drugs we're using. And then the wastewater, the water they use in producing this, they send it to the wastewater treatment plants to treat the water. And then also they send it to the hospital for, to use to treat people. From the hospital, these wastewater treatment plants, they treat the water. We consume the water, the ones that are good. The ones that are not good, that goes into our water body. It goes through the aquatic environment directly. And then this, from the hospital, of course, the hospital gives the drug to humans directly. And then they also, the ones they discard and they don't use, they have to send it, it goes into the water body also. And then from here, we can also use these pharmaceuticals to treat our animals in the farm, and we can use it to also, from the animals, from their feces, we can use it as manures for the plant. And here, from the water body, we can also use this water that has already been polluted. We can use them as irrigation water in our farm, like the way we do in the farm here. From this irrigation water, we can directly consume the plant. Let's say you buy your apple from the market, from the store, you don't wash it very well, you don't clean it very well. Even if you clean it, it already has some traces of pharmaceuticals in it. So you consume it, and it enters your body. You can also eat it directly from the meat, from the pig meat or from the cow meat or whatever you get from the market. And you consume it also in your body. And then one of the problems of this antimicrobial resistance is that the process when you're feeding this pig with these antibiotics, they tend to produce these antibodies, that resist these antibiotics with time. We talked about this in class. Even when you're treating plants with pesticide, you're trying to kill pesticide, they tend to adapt to that pesticide over time. So this is just similar to it. So these microbes here, they adapt to these antibiotics. And then you also, from the feces, they enter so from here, the summary of what I'm trying to say here is that you can get the pharmaceuticals from the water body from here, and you can also get the antimicrobial, the antibiotic, what's it called? Antibiotic resistant gene or something like that. You can also get them from these two. So the importance of AI in this is you can use AI to detect this antimicrobial resistance, these genes that produce over time, when they resist this, you can use AI to detect them. So let me go back to the previous page when I can. Yeah, some of the ways we can detect this AI is in the laboratory and in the field. You can pick samples from the water body or from wherever you want to analyze, and you go to your lab and you work on it. And you can also do the on-site, which is the institute, monitoring and detection. So in the laboratory, we have this liquid chromatography and the high resolution mass spectrometry. There are separation techniques you can use to, let's say you get the water, you can use it to separate the pharmaceuticals or the pollutants in the water from the water, So you can use AI to enhance these processes, like to enhance this technique. Instead of taking a longer time doing it by human, you can use AI to analyze a large number of data sets and make it easy. Also, in the field aspect, the field aspect for me, I think is more important because you're taking data, you're taking real-time information from the field, and AI can also help to enhance this process. So I'll call my the next person, the colleague to come ahead. Okay.
Next team member.
Yeah.
Yeah, so good morning. I'll be continuing from where he stopped immediately. Yeah, okay, so I'll also now be talking about how AI helps in ecotoxicity prediction. So as you can see from here, I said AI predicts risk assessment by predicting environmental toxicity and prioritizing high-risk pharmaceutical compounds. First of all, it helps in predicting toxicity using models like this random forest and this deep neural networks. It helps us to quickly predict chemicals. We're talking about pharmaceuticals, all those pharmaceutical compounds that could affect the environment. Then this PBT screening, the persistence by accumulation toxicity, it will help us to flag risky substances early so that we can be able to treat them. Then for the risk prioritization now, it helps us to prioritize out of all the pharmaceuticals, maybe pharmaceutical compounds that we've detected, which one should we prioritize first? Which one should we handle first and maybe address first? Then also AI optimized treatment technologies. Here we have technologies like advanced oxidation process, membrane bioreactors, and bioremediations. This advanced oxidation process helps us, it increases efficiency by 95%, and the benefits are optimized energy and reduced chemicals. Then also for the membrane reactors, the results, it helps us to, for reduced fouling. The benefits is extended membrane lifespan. So same thing for this. Please, because of time, I'll just move to the main slide. So unfortunately, Dr. Memley is no longer here. So the question he asked the other group, I wanted to address it here. So these are the barriers that we have in AI adoption. So I did it on the fishbone diagram. These are the barriers here. We have the data availability, we have the scalability, the technical issues, the human factors where we don't trust the output we get from AI. Just like we said AI is a black box. You don't know what you're picking from it. You don't know who imputed that information you are taking out to give others. So these are all the barriers. So I wish you were here so that we can address this better. Then also, most importantly, regulatory issues.
The video will be here, so he can watch it.
Yeah. So most importantly, these regulatory issues now. Policies need to be in place where people don't just go online. Maybe, for example, all this AI is what we impute is what the garbage in. People tend to get. That's what the garbage in is what the garbage out. So guidelines should be there to be able to guide people to probably the quality of information that is given out, the quality of information that people can access from it. Then we have all those limited funding. These are economic barriers. Then with all these barriers that we have now, then what is the future? What is the future plan? What is the roadmap? What should we do to help this AI adoption? Our future roadmap here, we said we can increase data infrastructure, explainable AI, hybrid models. Here, for the data infrastructures, we said we should implement fair data principles. Fair here means findable, accessible, interpretable, and reusable. So it should be that whatever data that is here should be able to be reused. You don't use it once and the data becomes useless. It should be a data that people can access all the time, make good use of them. And then also, hybrid models, we should develop, we should implement a multi-phase certification processes so that whatever data that is coming in, it should have a phase of certification that it passes through before it is implemented. You don't just bring it and it is implemented, because it affects future findings because people come back to use the same information. So it should be certified. Those information should pass through a certification process. Then explainable AI, this will help us in interoperability. Yeah, so also we talked about digital twins in our last class. We said we can create digital twins, make it an open access, just the way we have ChatGPT and the likes, and create maybe templates for common treatment process. Like you can go and get this information from them. Then this is the policy aspect of it, where maybe stakeholders now can continue the continuous stakeholder engagement. Formal validation standards should be put in place to validate. Standards should be put in place to validate that's the same thing I spoke about in the previous slide, the multi-phase certification process. The standards should be there to be able to certify those informations that are put out there. Then also interdisciplinary collaboration. So these are the 4 policies that we proposed for this paper. So I think to just cut it short.
Thank you. That's perfect. I think these challenges and the future of research in this area is very important. So we go to the the presentation before last, the one before last. Akelia and Adriana, they will be talking to us about AI in microplastic detection, risk assessment, and mitigation. So I would like to recognize one of our undergraduate students, Maya. She's here. She's from the what you call agriculture, a fundamental of agricultural engineering course, right? So welcome, Maya.
No, we're not 9 minutes. No, we're not 9 minutes.
It's group 3. Yeah, it's just like group 3.
You can use this. We find it. Okay. Thank you. That's okay. Thank you.
Okay. Good morning, everyone. I am Michaela Alex Malachi. It's an honor and a privilege to be here. And I want to say a special thanks to Dr. Fares and Dr. Adam, especially Dr. Adam, who worked with us even on the weekend. So today we will be presenting on artificial intelligence in microplastic detection, risk assessment, and mitigation. So one of our presenters bailed last minute, so it'll just be Adriana and I today. So please bear with us. So our outline is as follows. We have the introduction, AI in microplastic detection and monitoring, AI in fate transport modeling, AI in risk assessment, AI in mitigation and sustainable solutions, and lastly, the roadmap and future perspectives. So the objectives, it assesses the current state of AI-driven microplastic detection and classification methods. 2, summarize AI models for predicting the environmental fate and transport of microplastics. 3, it evaluates AI application in ecological and human health risk assessment. And the last one, it explores how AI can contribute to the development of sustainable plastic alternatives. As for our review methodology, we identified the review gap, because there is. We drafted a review title. We proposed the structure of the review. We used the PRISMA method. So for the literature search strategy, we use keywords like microplastics
AI in microplastic detection, mitigation, and all that. As for me, I pretty much place all the title in Scopus and Nature and Springer and the other search engines. And for the last part, we assigned team members for section and started writing the review paper. This is you.
You're okay. Hello, everyone.
Hello.
Okay, so picking up where my colleague left off with artificial intelligence and microplastic detection and monitoring, microplastics, due to their variation in size, shape, and chemistry, it makes them hard to detect. As I believe Oyo said, it's a silent, pandemic. That's epidemic. That's the same thing with microplastic pollution as well. Really, all of our pollutants, honestly. And so with AI, we can improve the identification and speed up the analysis of the microplastic pollutants and contaminants and handle large data sets at one time to reduce the labor cost and risk of, human error. And so continuing on with that, with computer vision for microscopy, we can use that to detect microplastic particles in various environments, because microplastic pollution is a very universal, global issue. And so with that, studies show that 90% of accuracy has distinguished fibers versus fragments. So that way we can detect, we know that we have 90% accuracy on detecting microplastic pollutants and microplastic pollutants only. There won't be a thing where we're using the naked eye and we pick up every little thing we see on the carpet, or whatever, we're looking at just pick up stuff. Computers are very detailed, accurate, and precise. And so with that, I'm going to switch back over to my colleague, Michaelia. Right here.
Okay, so artificial intelligence in freight and transport modeling. AI is used to describe how microplastics move through different environments by integrating hydrodynamics, particle characteristics, and local environmental conditions. Instead of relying on static or highly simplified models, AI can detect patterns in how particles travel, settle, or accumulate across space and time. So there are 4 risk assessment frameworks, and they're as follows. The first one is hazard identification. The second one is dose response assessment. Third, exposure assessment. And the last one is risk characterization. They all struggle with inconsistent data since species difference and nonlinear behaviors in microplastic systems. AI strengthens these frameworks by blending data sets that normally can't be compared, creating AI strengthens these frameworks by blending data sets that normally can't be compared or creating a complete picture of exposure and risk. So I'm not going to go through all of this table with the interest of time. So as for particle properties and toxicity depends on size, shape, polymer type, additives, and surface chemistry. The smaller the particles and fibers are, smaller particles and fiber often cause stronger biological effects. Weathering changes particle surfaces and can increase toxicity. AI identifies which properties drive harmful outcomes and predicts toxicity across diverse datasets. And I'm going to explain CNN, which is convolution neural network. And for the dataset, it's high content imaging. For the example application, it detects morphological changes in exposed cells. And the key findings enable automated feature extraction from microscopy images. For ingestion and bioaccumulation, AI is used to predict which species ingest microplastics, how much they accumulate, and how particles move through food webs. These models combine specific behaviors, environmental concentration, and particle characteristics to estimate the ingestion and retention more realistically. And for this one, we'll talk about the AI method, neural networks, and the organism is fish, the input data, environmental particle concentration, and feeding rate, and the output is probability of ingestion. For human exposure occurs through eating, drinking, and breathing. AI models estimate intake by combining combination data with dietary patterns, physiology, and environmental conditions. So for this table, we're going to talk about infants, the infant population, and the pathway is inhalation, and the exposure medium is floor dust. And the mean intake items per day is 180 to 250. And as for the retention fraction, it's 20. So they're more liable to retain 20% of whatever they inhale in their bodies. For epidemiology and public health, AI helps connect environmental microplastic measurements to health-related indicators. It can identify exposure hotspots, track contamination over time, and highlight communities or populations showing higher risk or vulnerability. So the application here that we're going to talk about is mapping regional exposure inequities. And for the data set, it's global contamination and population data, AI technique, gradient boosting. And for the key outcome, it's coastal megacities rank highest composite exposure index. So for risk assessment, what follows is detection and data challenges, where microplastics look different depending on where they're found. So it could either be in soil, water, air, or organisms. So detection methods often struggles. Techniques like FTIR or Raman can be slow or inconsistent, and the results rarely align across studies, making the data difficult to use for risk analysis. Opportunities for AI or machine learning. AI improves detection by speeding up particle identification, cleaning noisy data, and processing microscopic or spectral images that would take far longer manually. It also helps standardize results across different labs and studies. Linking characteristics to impacts. AI can connect particle traits such as size or chemistry to ecological or human health outcomes by modeling these patterns. It becomes easier to identify the particle types most associated with harmful effects, and to predict how they'll behave in different systems. For toxicity outcomes, across studies, certain patterns stand out. Smaller particles tend to cause stronger biological responses, different shapes behave differently, and chemical additives or pollutants can intensify effects. AI helps pinpoint which traits consistently drive toxicity. So for the particle property here, we're going to talk about polymer type. And the example endpoint is oxidative stress index. For the AI or ML method is SVM regression. And the major findings, it shows where PS, which is polystyrene, PE, polyethylene, and PP, I don't remember that one. It shows that PS is greater than PE and PE is greater than PP, which simply means that the lowest one that is ranking in toxicity here is PP. So for predictive ingestion risk, AI can estimate which species are most likely to ingest microplastics by looking at their feeding habits and particle availability. These predictions highlight high-risk organisms and help guide monitoring and conservation efforts. So we have the species here, we have the different feeding modes, the water concentration, and predictive ingestion rate, the model type, and the key prediction. Here for the mussels that are filter feeders, they have the highest items per meter cube that they ingest per day. No, sorry about that. They have, oh Lord, sorry, the new faces are throwing me off. Okay, so for the species, it's mussel, and the feeding mode is filter feeder, because they pretty much filter things to go inside the body so that, you know, they could consume that. So for water concentration, it's 1,200 items per meter cube. For the predictive ingestion rate, items per day is 5,200, and the model type random forest, key prediction, high risk 25% of retention. For human exposure, AI brings together food web data, atmospheric models, and water contamination level to estimate human exposure from multiple sources. When combined with demographic or behavioral information, these models help show how exposure varies between population. For epidemiology, AI integrates environmental contamination, biomonitoring results, and clinical indicators to explore possible links between microplastic exposure and health patterns. This helps identify trends earlier and direct public health attention where it's needed. So this is the last part for me. It's integrated risk framework. So this part ties everything together by showing the full AI supported risk flow, from collecting data to selecting features to training models to exploring scenarios and finally ranking risks. This process also uses explainable AI to make the results more transparent. And we have 3 scenarios here. First one is coastal aquaculture zone. Exposure score is 9, and the scale right there is 1 to 10. So for a vulnerability score, it's 8. Composite risk is 8.5. Suggested intervention, enhanced monitoring, and wastewater filtration. And as for my key points, AI improves how microplastics are tracked, identified, and evaluated. It links particle traits to effects, estimates exposure more realistically, and strengthens risk assessment by giving structure and clarity to fragmented data.
Okay, literally because of time. First, I just wanted to show that in the last 20 years, plastic production has grown from 234 to 432 million tons. Okay, so we're producing plastic, okay?
And more is coming.
And more is coming, as y'all could have seen in 2040, okay? So for this case study with real-time monitoring, what I said with computer visions, okay? So when we have a AMP robots is a reference that I use. They use camera setup, 3 cameras, all one of them was high resolution, 2 of them were not high resolution. And as you can tell, this is the setup that they had. They sent it through a long water thing. The computer used its camera to count and see the velocity and size and the travel path of the microplastic particles. You can see camera 1 is blue. Camera 1 was doing its thing this whole entire time, okay? The 2 cameras that were not high resolution and good hardware did not, which shows we need good hardware with this, okay? And so with case study number 2 is generative AI for polymer design. We can use AI to create our own design. So for example, badge holders. We all wear badge holders. We all have IDs. We all have that stuff. AI can create a all natural plastic substitute that is biodegradable, that does meet the environmental standards, so that way we won't have more microplastic pollution. With those challenges, lack of data, ethical concerns, black box models, we all talked about it. We don't know where the information is coming from and who owns that information. Energy footprint, using AI can take up to 3.5% of global electricity use. So we do have to make sure we use it sustainably. And also bias risk, underrepresentation of sustainable practice. If you've been building houses for 100 years, you're not going to trust a computer to tell you how to build one in 5 minutes. And so roadmap and vision, of course, same thing, real-time monitoring using the sensors, blockchain for transparency, and capacity building using our local extension agents, environmental agencies, and research institutes to be able to build up off of this data. In conclusion, artificial intelligence is not a standalone solution, but a transformative cornerstone. And we need to be able to integrate all predictive modeling, policy decision support applications, and integrate our interdisciplinary, so that way we can have science, environmental science, and computational modeling, so we can all work together to create a better environment for ourselves and progress towards a circular economy. Yes.
Thank you. Last presentation, it's gonna be 3 minutes each, so we should be done in 10 minutes, so that we can have the room for Bhagia to present her dissertation, her thesis. So I encourage you to stay for that presentation as well in support of your colleague for her defense. So all of you gonna be defending one day. So support her on that one. So with that, elevated speech, you just give an overview, no details, please.
Alrighty. Thank you. Hi, everybody. My name is Janice Torley. We're going to go through this really quickly. I am with Kinza and Madison. We are going to discussing the role of artificial intelligence and machine learning in pollution management, specifically on engineered nanomaterials. Oh, wrong way. So this is going to be everything we're going to go through. So our objectives are identifying the growth relevance and environmental concerns associated with engineered nanomaterials. We're going to call it E&Ms just for short. We're going to explain why traditional monitoring and risk assessment methods struggle to monitor and risk assessments methods struggle to evaluate efficiently, as well as highlight the emerging roles of AI and ML in improving E&M detection, prediction, and environmental assessments, all while providing a clear framework of how the presentation will connect E&M challenges to AI-driven solutions. So some potential health risks are E&Ms can enter the human body through inhalation, indigestion, or dermal contact, as well as they're extremely small in size, allowing some particles to even reach sensitive tissues and organs. We're going to skip over this one and this one.
Yeah.
So these are just some of the, I don't know where the pointer is at, some application of engineered nanomaterials in everyday studies. It's okay. And then why are traditional assessments, thank you, why are some traditional assessments of tools fall short, not standardized detection protocols of E&Ms in complex sampling, discussion are difficult to distinguish engineered versus natural nanoparticles, as well as toxicity testing and slow, expensive, and often inconsistent, and significant data sets gap in weeks environmental risk assessments. We're going to skip this one, and then
Yeah.
here's Madison.
Great, doing good.
So for the dual nature and environmental state of E&Ms, yeah, these properties, the properties that make E&M useful, like the high surface area and the reactivity, also poses a threat to like humans in the environment. And because of that, the process, this clumping process that changes the particle size and mobility, directly controlling their environmental reactivity and danger. That's what it does.
Why this matters?
Why does it matter? It harms us.
That's it.
Skip. Yeah, also, what's it called? Yeah, it can there's bioaccumulation that occurs, and there are also exposure routes, which can cause oxidative stress, and it can destroy your lungs. The methodology that we use
was explained before.
Yeah. Prisma, we went through a bunch of articles. Next, machine learning techniques. We looked at support vector machines, random forest classification, and regression trees, principal component analysis, along with the deep learning models, CNN, RNN, BNN. They're all very useful, especially when combined in helping to like determine toxicity characteristics and whatnot regarding E&Ms and environment. Yeah, here you go.
Good, thank you.
Oh my gosh, I forgot about that. Right? Oh, okay.
Okay, I'm just gonna go through two case studies. The first one I'm gonna go through is predicting nanomaterial toxicity with support vector machines. Researchers basically wanted to predict if titanium dioxide and zinc oxide particles were toxic without extensive lab tests. They used the SVM model that found complex patterns in the data. They found that the model could be over 85% accurate at predicting if a nanoparticle was toxic, and this just allows for this allows for scientists to be able to check the safety on through a model before actually doing something in the lab. And then the second one I'm going through is the identifying morphology with convolutional neural network. It's a deep learning architecture for image analysis, and it was trained on thousands of labeled micrographs. And I think this image is going to help you understand exactly what happened. And so the model classified nanomaterial morphology and predicted 95% accuracy for toxicity. It also identifies specific structural features such as the sharp edges and high aspect ratios that were correlated with cellular membrane damage. And so basically it just helps as a scalable method for the large scale risk categorization of existing and future nanomaterials.
What are the key challenges? Let's go to the last one.
Oh, yes.
Key challenges. What's the future? And let's.
Yes, that's what I'm going to.
Yep.
So obviously you guys know what we talked about. And so the future is that we should develop, expand, improve, investigate, and integrate. We should obviously develop better harmonized methods for E&M detection. We should expand large high quality data sets needed to train reliable AI and machine learning models. We should improve AI transparency, investigate a long-term environmental and health impact. And then we should integrate AI with real-time environmental monitoring tools and nanosensors for early detection and risk mitigation. That's it, guys.
I like this team.
Stay to the point.
Well, I really thank you. I mean, in 1 minute closing, I would like to thank you all for the great effort that you really put together forward for this term projects. Encouraging you to continue the momentum. As I told you before, we can work on publishing this work. So it's really up to you if you want to go to the next step or not. We are here, Dr. Vito, Dr. Rahman, Dr. Adam, Dr. Awal as well. We are here to help you to get to the next level. Well, thank you, Mia, again for coming and for supporting our graduate students. I hope to see you as another graduate student soon. With that, thank you. And Bagia, sorry for being late for your defense, but we are here. So we'll